Okay, let's take a look at some different ways to write linear functions. We have three different forms. The slope-intercept form is probably the most common, which is y equals mx plus b, m being the slope, and b is the y-intercept. The next form we're going to look at is point-slope form. Its general formula is y minus y1 equals m times the quantity x minus x1. M is the slope, x1, y1 is any point on the graph. So this is helpful if we don't know the intercept, but we do know a point. And the final form is standard form. Ax plus by equals c. A, b, and c are constants, and they're integers. I find that this is the least helpful form because there's no information that you can gather directly from the equation. You have to manipulate it a little bit before you can get some information. One thing that helps me remember point-slope form is by connecting it to the slope formula. So if I had 2 points, the first point is xy, very generic. The second point is x1, y1, which is a specific point. I could write out my slope. M equals y minus y1 over x minus x1. So that would be the slope of these 2 points. And if I rearrange this formula a little bit, I will get my point-slope equation. First thing I can do is multiply each side by x minus x1. And I find that this and this will divide out to equal 1. And this can be rearranged. So let me just rearrange. I'm going to put my y's first. Y minus y1 equals, I'm going to put my slope first, m times x minus x1. That looks like that point-slope formula. Very easy to remember if we're thinking about the slope formula. Okay, so then we can do some examples with this point-slope stuff. So let's take a look at a few ways we can use it. Okay, our first example. The equation y minus 5 equals negative 2/5 times the quantity x plus 3. The first thing we're asked to do is to sketch a quick graph. Well, I know 2 pieces of information because this is point-slope form. I know the slope, which is negative 2/5, and I know a point. Now we got to be really careful because the point-slope form is y minus y1 equals slope times x minus x1. So I have a plus 3, which means in order to follow the formula, I actually have a negative 3 because a negative minus a negative 3 gives me the positive 3. So my point is negative 3 for the x, and this is fine because they're both minus, so positive 5 for the y. Watch out. That's my important information. Now let's go ahead and graph that. I will start at my negative 3, 5. So 1, 2, 3, back towards the negative direction, up 5. 1, 2, 3, 4, 5. And place my point there. Now slope says to move down 2 and to the positive direction 5. 1, 2, 1, 2, 3, 4, 5. Down 2 over 1, 2, 3, 4, 5. And I can even add a point going the other direction. If I flipped my negative to the 5, I would be going up 2, 1, 2, and back 5. 1, 2, 3, 4, 5. You can sketch in that line there. And I can see I have a decreasing slope. It's kind of more flat than just a slope of 1. So it seems like I did that correctly. Okay, next part is to change the equation to slope-intercept form. So I'm going to rewrite my equation. Negative 2/5 times the quantity x plus 3. Okay, so the first thing I need to do is eliminate those parentheses. I can do that by distributing. So rewrite this side Now I'm going to distribute. I get negative 2/5 x minus 2 times 3 is 6 minus 6/5. Now I want to eliminate this minus 5 here, so I'm going to add 5 to both sides. Ooh, I'm adding a fraction and a whole number. So I'm going to have to do some manipulation here. So minus 2/5 x, or negative 2/5 x. Let's take a little detour over to the side here. And I have negative 6/5 plus 5. Let me put that in terms of fifths. That would be 25/5. So need to add that together. I'm going to have more positives than negatives. So I'm going to have positive 19/5. And it's kind of ugly, but I have my slope, I have my y-intercept. And 19/5 is almost 20/5. 20/5 would be 4. Let's take a look at our graph. 1, 2, 3, 4. Yep, I see that my graph crosses the y-axis slightly below 4, which would be at 19/5. So here it is. I'm going to box it or circle it. That would be in slope-intercept form. Now it says to change the equation to standard form. Well, first of all, I don't want any fractions in standard form. So let me rewrite this again. Y equals negative 2/5 x plus 19/5. And in order to get rid of those fractions, I'm going to multiply everything in the entire equation by 5. So I'm going to get 5y equals 5 times negative 2/5. Well, if I multiply the top by 5 and then divide by 5, that 5 is dividing out. So then I just get negative 2x. Plus, again, if I multiply the top by 5 and then divide by 5, I'm going to divide those 5s out to be 1, so plus 19. So now I've gotten rid of all of my fractions. So I'm going to just write a note to myself. Eliminate fractions. Then the next step is to just rearrange it. So I want to have ax first. So I'm going to add 2x to both sides. So then I have 2x plus 5y equals 19. There's my ax plus by equals c. I'll just circle that as best as I can. I write another quick note to myself. The second step after we eliminate fractions is to rearrange algebraically. So we can't just move things around. We actually have to add or subtract algebraically to get it in the right form. Let's do one more example. We have the equation y plus 2 equals x, or 3x. Y plus 2 equals 3x. Doesn't look like I'm in any special form, but what if this had a plus 0 here? That almost looks like point slope form. Actually, it could be point slope form. So let me change this around. Y plus 2 equals 3 times x minus 0. I put plus 0 before, but I'm going to put minus 0 because it kind of follows the format of point slope. So given this, which is the same as what I started with, it was a little tricky. Now I can sketch a quick graph. My slope is 3. My point is 0. Ooh, is this negative 2 or positive 2? Well, my formula has y minus y1. So this has got to be a negative 2. It's always opposite. So using those important pieces of information, let's go over here and graph it. I start at 0 down 2. And by the way, if I were really graphing this, I probably would just have rearranged this into the slope-intercept form first, but I did want you to see how to start with the point-slope form. Okay, slope is 3, so up 3, 1, 2, 3 over 1, up 3, 1, 2, 3, 1, 2, 3 over 1. If I wanted to go backwards, I could do negative and negative, so down 3, 1, 2, 3, back 1. And that should be enough points. We'll connect those. Change the equation to slope-intercept form. Well, if I were to start with that original equation I was given, it's pretty easy. Just subtract 2 on each side. Y equals 3x minus 2. And yet we see it crossed at negative 2. And the slope is still 3, so that was pretty easy. Change it to standard form. Again, we don't have any fractions to deal with here, so it's just a matter of rearranging it. So I would just, let me start with slope-intercept form. I need to get my y on the other side. So let's add 2 first. Y plus 2 equals 3x. Oh, we're back to where we started. Subtract the y. So we get 2 equals 3x minus y, which is the same as 3x minus y equals 2. There we have it. And one more note, by the way, you might have just seen that it might have been easy to subtract that 3x. The only reason I didn't is because that first coefficient, the x one, is typically written positive. So I wanted to subtract the y so that I would have a positive coefficient in front of x. If you ended up with a negative coefficient in front of x, you can always just multiply the entire equation by -1. And it's not a big deal. It's pretty easy to switch it over.